So now we'll go into the next part in the basic static analysis, which is the BE header. And for Windows executable files, and that's actually something you would see in every single type of files. In executable files on Mac, on Linux, on Android, wherever they always start with a header and then the data. Most of the files in this known internet planet, they always have a header that tells us more information about this file. What is the size of this file? What's the content? How this content is divided? And what is this file type? Is it a picture? Is it an executable file? Is it what type of executable file? Is it Windows executable? Is it Linux executable? And so on. And this header is basically organized in a specific way to represent some specific information. If your program needs to load let's say a video, it needs to know how the pictures are encoded, how the audio is encoded, what's exactly the algorithms that's being used, and so many information. What's the width and height for the video, and so on. For the executable files, we have the exact same thing, and we have basically in Windows executable, we have two headers. We have the DOS program, because before Windows there was a DOS, and the DOS had also .exe files. And there is a small DOS application in every Windows application. If you have any Windows executable file, it starts with a DOS small application, and then a Windows, and then the whole Windows application. There is the MZ header, which represents the header for that executable DOS application, and then we have the BE header, which is the header for all Windows application. BE header gives so much of flexibility to executables after the DOS world, and it allows any application to have the code separate from the data, separate from the resources like the icons and additional text and the file version and the additional pictures inside the program, and all separate from some other information that are important, like certificates and so on. And this detach between code and data is very, very important, and we use it a lot from our malware analysis. Also, executables are more expandable in memory. So on disk, they might be 200 kilobytes, let's say, but in memory, it might be 250 kilobytes in size. The reason for that is working with the disk sectors compared to memory pages. Memory pages are mostly bigger than the disk sectors. This is one reason. Some other reason is that some data, it starts with being empty. In like some variables, let's say, that the code will be using, or the executable will be using, some areas in memories. He doesn't need to have initial data for them, but he will put data inside these areas in memory along when it's being executed. So these areas doesn't have to be an empty data inside the disk, but they can be shrunk. They are not existent on the disk, and when the application is loaded in memory, there is a space for the application to space in memory that they can save some information, save some settings, and along the time while it's running. So this also what makes the executable smaller on disk than in memory, and other stuff. So that is one of the uses for headers. One thing I want to mention, one last thing, is that BE header also supports something called dynamic linking. What is dynamic linking? With our application nowadays, if you look at, let's say, a game, for example, this game needs to access so many different code to just be able to show the pictures and the images and the 3D images along the time. They need to access DirectX or OpenGL. They need to access some Windows libraries for calculations, for user interface. They need to access some libraries that works with pictures encoding, like JPG, PNG, all of this type of pictures. They need to access libraries for sound, libraries for the game engine, and its additional libraries being developed by another team, and so on. And for that, you cannot have all of this information, all of this code from the 3D, from the math to 3D to game engine to the actual game, all inside one exe file. And imagine if there's other game that uses most of these functions or most of this 3D and the engine and so on. It will include so much of duplicate code from the first one to the second one. If you have all of them linked inside, all of this code is being inside the application, each exe file will be over 100, 200 megabytes, each exe file, and you will have so much of duplicate code along different executable files. But what Windows decided to do is that let's have all of this 3D functionality and game engine and all of this stuff in separate files and call these files libraries. These libraries are being loaded with the executable in the memory when it's being running. When it starts to run, it's loaded inside its own memory, and the application can access its functionality in an easier way. So if an application needs to access some mathematical things, some mathematical function, there is a library called math.dll, which will be loaded with him in the memory, and it has so many mathematical functions he can access, like sine, cosine, tan, whatever the type of function he wants to use. And there is an easier way to access these functions from inside this library wherever it's being loaded in the memory. If it's loaded in the address 1000 or the address 5000, where it's being loaded in memory, this application needs to access its functionality in an easy way. And that's what we call dynamic linking or dynamic linked libraries. And all of that is being described through something called import table inside the header. So there is something inside the headers called import table, which says which libraries this application depends on and which functions he will use inside these libraries. So Windows can make the connection between these libraries and the application much easier, much more smooth, and basically flawless. We will talk about it a bit later. And that's basically the BE header. As well, it can include some information about the processor, about the Windows version, the minimum Windows version to run on, and so many things like that. So the BE header looks like this. If we have any application, like Simple, for example, the application is a massive blob of data. And this data is basically divided into two parts, headers and sections. Headers, as we explained, that has the DOS program, has the Windows executable program, and has something called data directories where it links to the import table and different things. And then, and you have also the section table. We'll talk about it now. Sections here are basically all the different parts of the program, the code, the data, the resources, which is the icons and so on, all in separate sections, and each section has different permissions inside memory. One section can be only executable or can be readable and executable. You cannot modify its data inside the memory, and as well, this is the only part in the memory that can be executable. There is the data where it's readable and writable, but it's not executable. You cannot execute code inside this part. So the BE header looks like this, or any executable file. When you open it in a hex editor, or you open it even in any editor, it will look like this. It will start with MZ at the beginning, the first 2 bytes, then some random data, and then you see this text. This program cannot be run in DOS mode. And as you see, any application starts with a DOS, small DOS application that prints this text. This program cannot be run in DOS mode. Then after that, it starts the Windows code. And this is a very good signature. You have to save it in your mind to know that this part is an executable file. If you see that part in memory, you see it in a bcap, you see it in a you see it in the middle of an executable file, you see it anywhere, you know that this is the beginning of an executable file. So you can, if you see it inside the bcap, you can save all the data from start from MZ until the end, and it will include an exe file that you can analyze, you can read, you can reverse, you can do whatever. It starts with MZ, which is the beginning of the file and the beginning of the DOS application, that this application prints this program cannot be run in DOS mode, and then after that some random data until you see this PE. This PE represents portable executable, and this is the start of the Windows header. So this is everything after is related to the Windows application. And the Windows application is basically divided into multiple sections. First is the signature, which is the PE, then something called file header, then something called optional header, and it's not optional at all, it's always there, and it's very important. And the last is the data directories. The file header has some important information that you will need to look at to understand this header. We'll be looking at these headers through programs like PE Studio or CFF Explorer or PEID. There are multiple products that can show us this header and show us the values they have. And some of these values are really important for us. For file header, what's important is something called machine, which tells us if it's a 32 or 64 application, the number of sections, and the time date stamp. And this time date stamp is not like the modified date or access date or date time or all of these dates. Time date stamp is the compilation date, is the time when the attacker decided, if it's a malware, the attacker decided to compile this file and use it to send it to someone to attack him. It is the original date of that file on any system. Time date stamp is really good indication of when this malware has been created and how long it is there in the market. It doesn't say about the family though, because this malware could have been for 3 years, but this file, this version, this exact version with this hash has appeared first time on that time date stamp. The attacker can still modify it, but most of the samples they don't. And last, something called characteristics, which tells us is it an executable file, an executable application, is it a complete application, or is it a library that feeds the other applications with data? Some malware prefer to be a library because they don't have their own process. They are not loaded as a normal application. They are not loaded as a separate executable. You can see it in task manager, or you can see it in the process list or whatever. It's being loaded inside another program realm, inside another program memory, as it's a library to feed it with some functionality. So if the file is a library, it can be loaded inside Internet Explorer, it can be loaded inside Chrome, it can be loaded inside the Explorer.exe, it can be loaded anywhere else. It can be seen as a browser extension, or it can be seen as a Windows library. It can disguise itself as a Windows library loaded in any application. So libraries, we see so many malware using the library type of executables, so they can basically have the malware blend inside all the processes that are being loaded at the same time. For a Surface, for example, it can be also a library, and if it's a library, it will be loaded inside svchost.exe. It's basically a Surface host by Windows. It's an executable file. Its main goal to load surfaces as libraries, as DLLs inside its own realm and make sure it's executed properly. And also, if it's a driver, we will know from the characteristics of it. This is the file header, and this is all the information that's included in the file header. Mostly you will be using the machine, the number of sections, and the characteristics as well. And the optional header has more important information for us. The first one is the address of entry point. This is the start of the code. This is where the program starts to run. If you have been familiar with C++ or any known language, it's called the main. This is the start of the main function. And the start of the code is not the beginning of the code section in all times. It could be, but it could be somewhere in the middle of the code section. There's a lot of code inside the code section, but in a function in the middle, this is the start of the program. And it's important for us if we're doing static and code analysis, static or dynamic code analysis, to start the analysis from the entry point. The image base is where the program will be loaded in its own memory. Every application is being loaded in its own virtual memory, which is 4 gigabytes in 32-bit, and it's a bit more in 64. And this image base is basically where this program will be loaded in this virtual memory. As every program has its own virtual memory of 4 gigabytes, the program can choose where it would like to be loaded. It's a massive memory for him. He can choose where he likes to be loaded. For exe files, they're mostly being loaded in the place where they like. If the well, depends on the file structure, but this image base is the preferred place for the executable to load. Some libraries, there's so many libraries who have the exact same image base, so they cannot all of them load in the same exact place. So one of them will be loaded in the place where they all preferred, and then the others will move into other places in memory. Image base is just an indicator of where it's preferred to be, but it's not always where the program will be loaded at. It's just most of the time, and it depends on different Windows security features as well. Then you have the minimum Windows version, the major and the minor, which is like, say, the Windows 7 Service Pack 1 or Windows XP Service Pack 3 or something like that. And then the size of the program, the size of this executable in memory, and sometimes it's more inflated than where it is on disk. The subsystem, which is either it's a UI application, it's a console application, it's what's exactly the realm it's been running at, and the data directory, which includes more information that we might use. And data directories are really the optional part. Some they have, some they don't. They can have a resource table where they have the icon, they have different information, they have additional files or additional pictures. Some programs, they don't. They might have an import table, or mostly they have an import table where they have all the libraries they use, and as well all the functions or the commands they use from inside these libraries, like math.dll, and I want to use sine and cosine and tan. I want to use libraries like kernel32, which is a Windows library and very known Windows library that most of applications use, and or almost all of them. And kernel32 has functions like create file, open file, delete file, and things like that most of applications might use to interact with their own files. So you will see that they say in the import table, I want to use the library kernel32.dll, and I want to use open file, create file, delete file. Now for you as a malware analyst, you can understand, okay, it looks like it does some file manipulation. I see, let's say it uses a library called WinInit, and this is used mostly for Windows inet.dll, which is mostly used for internet communication. And you can see commands that this application is using called HTTP connect, HTTP send request, HTTP receive file or download file. So you can understand, okay, it might be communicating to the attacker through HTTP. This is good information to for us to understand what's the protocol it might be using to communicate to the attacker, and stuff like that. On the other hand, the export table is when you are developing a library, or when the malware is actually a library and it has some functions that it's exported publicly by any application to use. So let's say you have a malware, and there's a malware has a command called install malware, and this command it should be used from another application, or a command, or you are creating a library called math.dll, and you want to export some commands so other applications can be able to use them, like sine, cosine, tan, as we know. So export table is basically has the commands that this library export to the world. Some malware include some export table functions, and some malware they have additional modules. That might be the malware is a backdoor, but it can download. They have an additional module for keylogger. They have additional module for credential theft. They have additional module for spreading through network, and so on. And these modules are basically libraries that being loaded, and they have some functions like install, execute command, whatever the functions they might have in their export table, so the malware can interact with these modules and execute these commands for them, and basically able to integrate this module inside the malware functionality. Resource table, as we said, for icons, images, and so on, and something called relocation table. Relocation table, as we talked about in the image base is the preferred place for the executable to be loaded inside its own virtual memory. But if it's not able to be loaded in that place, you need to have the relocation table to be able to relocate the application to another place in memory without messing up with the code, without having problems and having errors in the code. The code mostly have like direct access to specific addresses to memory, and these addresses, if the program has changed its own place, these addresses will be all corrupted, and there will be a big mess happening in the code and so many errors. Relocation table helps to relocate the BE file, relocate the executable application from an area in memory, or its preferred area, which is the image base, to another area in memory without causing these errors. It modifies all the addresses inside the code. It makes the program run smoothly. It's not included in all executables, but it's included in all libraries, all types of DLLs, and some of the exe files. If it's not included in exe file, this file will be always loaded in its own image base, regardless of the situation. It will be always loaded there. So this is basically most of the headers. The last header we have is the section table, which includes section name, maybe .text, data, read only data, and whatever the section name, and then includes some information about that section. Let's say the virtual address is where it starts, the virtual size when it ends, and as well the row address where it is on disk, not on the memory, but where it is in disk. And the row size is where what is its size in disk as well. This is basically all the information that's included. One more information is the characteristics, which is it executable, is it read-only, is it writable, and so on. This is a screenshot from BE Studio, and you can see here all the sections are being included inside this file, and as well if it's executable. If it's read-only, you should only see one section that is executable. This is most of the applications, that the first one, .text, is the executable code section, and then the others are the data. For example, it's writable and readable. The R data is read-only, the resources is read-only, and so on. And there's nothing else that is executable after. So this file includes two sections that are executable, which is something a little bit strange. And as well, it includes, that's why he sees this section as blacklisted. He make it in red, because this is something that is not common. Most of the sections start with dot, and there are common names for them like .text or .code, .data, .rdata, .idata, .rsrc for resources and .reloc .reloc for relocations. Apart from these names, this is the most common names that you will see. Different names might be something suspicious, like UBX1, 2, 3, or UBX0, UBX1, UBX2. These sections are probably related to UBX compressor or backer, and so on. Also, ASPAC, it's a name of a section, and might be related to ASPAC as a backer, and maybe this file is basically backed, and this is the code where it unpacks the malware in memory and executes its code. And this is some of the information you might find useful inside the section table. So with the BE header, when you look at an executable file, you look at a BE file through BE Studio or whatever the app you will be using, there are some things you'll be looking at. One is the import table, which tells you about all the functionality this malware might be using. The file changes, registry, does it modify files, does it modify registry entries, does it connect to the internet, what exactly the type of protocol. Sometimes you might know from HTTP Connect, for example, for HTTP, or URL download to file, which is mostly used by downloaders, and so on. So import table can tell you a lot about the actual the functionality of the malware. For export table, it will tell you that this is a library, not an executable, and as well it will tell you might be this is a module inside a malware, or is it the full malware? Does it have what is the actual start of the malware? It might be the actual start is not the entry point of the application, but one of these functions that are included in the export table. The resource section can tell you as well if there is any additional executables inside that file, and this is something is quite common for droppers. When the malware itself is dropping another malware inside the application data or temporary folder and execute that, and then the dropper itself deletes itself, and it's like has never been before. And this is something we see commonly, and we see that the malware, the second malware, the dropped malware, is stored inside the resource section. Or sometimes we see in the resource section the malware configuration, maybe a zipped file, maybe the legitimate file as a decoy, as a let's say a malware is called let's say Jennifer Aniston.png.exe, and the person click on it, they think it is a picture of her, but it's not, and then the malware runs and it replaces itself with the actual picture of Jennifer Aniston, which makes the user think that everything is working normally, while the malware has installed itself in the application data or something like that. So from resource section, we can see so many things that represents the malware. Section names can tell us if this file is backed or encrypted, and can help us also know what is the encryption is made by which backer, if it's ASPAC, if it's UBX, or whatever the section, whatever the backer is, as well as the section permissions can also tell us if this malware has any encryption there, or it looks like backed, even if the section names look normal. So if we see a section, let's say the last section or the first section is read, write, and executable, is readable, writable, and executable. It never happens in a normal application that it is that there is a section that's executable and writable at the same time. Having a section that's writable and executable means that this application has a self-modifying code. This is code that decrypts itself or modifies itself while it's running. This is itself a kind of a known behavior for backers, encryptors, and also malware. So this is something should be suspicious for you, and this is something you can look at. Entry point can represent if this malware is encrypted or not, because entry point mostly, or in all the application, it points to the first section. When it's pointing to the last section or a second or third section, this is something itself is strange and could represent that this malware is encrypted. It's not always that if the malware is encrypted, the entry point is pointing to the last section or not to the first section. But if you see it outside of the first section, that's something that could represent that the malware is backed. Timed stamp, it's the compile time. Timed stamp can be used for threat intelligence and the way of understanding which variant was released first. If you have, let's say, 100 sample from the same variant, from the same family, but different variants, you can paint a map on which version was released first and how many changes happened along the time, as well as you can know from the compilation time which time zone this program is. All of these programs has been been compiled at, and you can know what time zone the attacker is living at. If he's living in Russia, so we see that most of the compilation time suits 9 to 5 GMT plus, 9, for example. I don't know about Russia exactly, but let's say something like this. So that's also one of the ways that we can assume the country of origin, which can help us if we find other evidences. We can say that for sure it might be Russia or China or something like that. The last thing is section permissions, which can reveal if this malware is backed, is it encrypted, if it has something unusual. So we can say, let's say, if the permissions is read-write executable for the last section, that probably that it is already backed, it's encrypted, and the malware or the unbacking code starts in the last section. So all of these things can help us identify if there is something suspicious happening. So that's it for the BE header, and now we'll move to the behavior analysis and code analysis.